In our very first evidence file, we looked at the numbers that run the universe: the strength of gravity, the mass of a quark, the energy baked into empty space, and we found them sitting on a knife's edge. Change several of them by a hair, and there are no stars, no chemistry, no us. We said that's not proof of anything. It's a weight on a scale. But there's an objection to that weight so strong, so widely believed, that if we don't meet it honestly, everything we built in episode 1 is exposed. Tonight we meet it. And a cosmologist named Bernard Carr put the whole standoff in one sentence. If there is only one universe, Carr said, you might have to have a fine-tuner. If you don't want God, you'd better have a multiverse. So this isn't an evidence file. Tonight is a Steelman Showdown. And the rule of a Steelman Showdown is uncomfortable. We build the other side's argument first, and we build it so well that a physicist who believes it would watch this and say, yes, that's exactly right. No straw man, no cheap shot. If we're going to weigh the multiverse against design, we owe it the strongest version there is. So let me make the case for the multiverse. Better, maybe, than you've heard it made. Here's the move, and it's elegant. What if ours is not the universe, just a universe? One bubble in an unimaginably larger foam. Start with real mainstream physics. The leading theory of the Big Bang's first instant is inflation, a fraction of a second of runaway expansion. And in most versions, once inflation starts, it never fully stops. It keeps going in region after region, endlessly budding off new pocket universes. This isn't fringe. Alan Guth, Andre Linde, Alexander Vilenkin, the architects of inflation, take eternal inflation seriously as a consequence of the math. Now add string theory. In string theory, the constants we call fundamental aren't fixed by law. They depend on how extra dimensions are folded up, and the number of ways to fold them is staggering. Current estimates put the landscape at around 10 to the 500 distinct possible vacua, each with its own physics, its own constants. Put those two ideas together, and you get the multiverse. Eternal inflation is the machine that spins up bubble after bubble. The landscape is the menu of physics each bubble can land on. Somewhere in that vast lottery, a universe comes up with our winning numbers. And here's the part that makes fine-tuning evaporate: the observer selection effect. We could only ever find ourselves in a bubble whose constants permit observers. Asking, why is our universe fine-tuned for life, becomes like asking why every planet we've ever stood on had breathable air. Of course it did. We couldn't be standing anywhere else. And if you think this is just philosophy dressed up, here's the card that should stop you. In 1987, the physicist Steven Weinberg, a Nobel laureate and no friend of religion, used exactly this reasoning to predict something. He argued that if the energy of empty space, the cosmological constant, varied across a multiverse, then observers would most likely measure a small, non-zero value, because a large one would blow galaxies apart before life could form. At the time, most physicists expected that constant to be exactly zero. Then, in 1998, we measured it. It was small and non-zero. Right in the window Weinberg's anthropic argument pointed to. Sit with that. The multiverse isn't only an escape hatch from a hard question. It is a framework that made a genuine, risky prediction and got it roughly right. That is the Steelman. If you're going to answer it, you cannot wave it away. I meant every word of that. It's a serious idea, held by serious people. So let's respond the way this channel always does. Not by mocking it, but by finding where it's actually load-bearing and pressing there. 4 honest points. 1. The multiverse doesn't erase the fine-tuning. It moves it up a floor. The machine that makes the bubbles is not free. Eternal inflation needs an inflaton field with a very specially shaped potential, and it has to begin in a staggeringly low entropy state. Roger Penrose, no theist axe to grind, put the precision of that starting condition at 1 part in 10 to the 10 to the 123. That's not a typo you can round off. The landscape needs the deeper laws of string theory to be just so. So you haven't dissolved the tuning, you've relocated it into the mechanism that generates the universes. Who fine-tuned the fine-tuner? 2. By construction, we can't see the other bubbles. They are, by definition, causally cut off from ours. No light, no signal, ever. That's not a temporary gap. It's built into the theory. In 2014, two respected cosmologists, George Ellis and Joe Silk, wrote a piece in Nature literally titled, "Defend the Integrity of Physics," warning that a multiverse invoked to explain away fine-tuning, but which cannot be tested, risks trading science for something that only looks like it. The honest chain is known physics to hypothetical physics to multiverse. Each arrow is a leap. 3. And this one is strange. If the multiverse really contains infinitely many observers, you have to ask which kind is typical. And on many ways of counting, the overwhelming majority of observers in an eternal multiverse aren't evolved beings on planets. They're Boltzmann-brains, momentary conscious fluctuations that pop out of the vacuum with false memories and vanish. If that's true, you are far more likely to be one of them than to be a real person reading real physics. Which is self-defeating, because a Boltzmann-brain's evidence for the multiverse is itself a hallucination. The atheist cosmologist Carroll takes this so seriously, he argues any theory that predicts we're Boltzmann-brains should be rejected for that reason. Nobody has a settled fix. It's called the measure problem. How do you even count observers across infinities? And it is unsolved. 4. Even a real multiverse may not explain the thing we care about. Philosophers Ian Hacking and Roger White pressed this. Suppose there are countless universes. That still doesn't raise the odds that this one, the only one you can actually observe, would be life permitting. Walk into a casino, see one gambler roll double sixes, and conclude, he must have been rolling all night. That's a fallacy. The other rolls don't touch this roll. Likewise, other universes don't explain why the universe you're in came up habitable. You still have to explain the one on the table. So where does that leave the scale? Let's be scrupulous, because it would be easy to overclaim here, and that's exactly the move we don't make. The multiverse is a live, motivated hypothesis. It grows out of real physics, and it made a prediction that worked. We are not going to tell you it's been refuted because it hasn't. But notice what it does not do. It does not make the fine-tuning go away. At best, it relocates it into a mechanism that is itself finely set. It leans on other domains we can't observe. And it drags along the Boltzmann-brain and measure problems that, right now, no one has solved. And here's the deepest point, the one Carr's clever line quietly hides. God or multiverse is a false choice. A creator could perfectly well make a universe-generating multiverse. The two aren't rivals at that level at all. Which means even if the multiverse is real, the design question doesn't vanish. It just gets asked one floor up. Why is there a law-giving structure rich enough to make universes at all? Why is anything here ordered and rational enough to be understood? A multiverse doesn't answer that. It inherits it. So the needle we moved in episode 1 does not snap back. The multiverse is the best rebuttal there is. And the honest verdict is that it's a serious idea that survives, but does not defeat the inference to a mind. It moves the question, it doesn't close it. And let me say plainly what would move this the other way, because that's the promise of this channel. If cosmologists find independent, testable evidence of other domains, a scar in the sky from a bubble collision, say, or if someone solves the measure problem so cleanly that the anthropic prediction stands on its own and the mechanism's tuning is explained, then this rebuttal gets much stronger, and we'll say so. We're not afraid of the multiverse, we're watching it. Step all the way back. One universe, or a trillion? The oldest question doesn't move. Why is there something rather than nothing? Leibniz asked it 3 centuries ago, and no multiverse touches it, because a multiverse is just more something that has to be explained. Behind the whole ensemble, whatever its size, sits the same quiet fact, that reality is ordered, that it's rational, that it can be read at all. The scriptures don't count the universes, they point past them. In the beginning, God created the heavens and the earth, the whole of it, however wide it runs. And John reaches under the physics to the thing holding it up. In the beginning was the Word, the Logos, reason itself, and through him all things were made. Paul says it in the line this channel keeps returning to, in him all things hold together. I can't hand you certainty from a cosmology paper, and I won't pretend to. The multiverse might be real. If it is a breathtaking piece of a creation far larger than we guessed, and it still leaves you standing at the same door Bernard Carr named, asking who lit the whole thing. Evidence raises the odds. Trust takes the last step. And that's true of knowing any person. Examine the dark honestly. Watch for the light.